So today's demo has to do with using a microwave oven and processed American cheese to calculate the speed of light. So for this wave unit, we only had one equation. V equals F lambda. The velocity of a wave equals the frequency of the wave, how many times per second, times the length of the wave. So length per second, meters per second. In a microwave oven, the microwave works just like a tuning fork on the water molecule. With a tuning fork, you hit a tuning fork and the two arms vibrate back and forth like that based on their certain size and shape, and they make a steady tone. In the water molecule, you've got this massive oxygen atom and these two tiny little hydrogen atoms at 72 degrees apart from each other up at the top. And if you hit it with the right frequency, those two little hydrogen start vibrating back and forth very rapidly. And they vibrate very, very quickly. So the microwave puts out that frequency to get those hydrogen atoms vibrating and warming up the water molecules. And they vibrate at a frequency of 2,450 megahertz. And mega is million, so that is 2,450,000,000 vibrations per second. That's why things heat up quickly in a microwave. So we know the frequency that the water molecules are vibrating at. Now we just need the wavelength in order to find the velocity of light. So if you take and look at an interference pattern, when you have waves bouncing around and running into each other, when two waves come in and hit, if they have the peaks hitting at the same point, you get a high peak. If you have the troughs at the same point, you get a depression. So in terms of what this means for a microwave, there is a transmitter on the side blasting these microwaves out into this metal box. And they're hitting the sides and the top and the bottom, and they're all bouncing around everywhere. To heat the food evenly, they put a turntable in there which rotates the food so it gets covered with all sorts of waves from all directions. But if you take the turntable out, you just get a pattern like this developing, and you have a whole bunch of hot spots with a bunch of cold spots in beneath them. So if you put this up and look just at the very hot spots, you end up with a pattern of dots of hot spots, and the distance between the hot spots is one wavelength. So if we take our processed American cheese and we lay a whole bunch of slices of cheese out on a piece of cardboard and we stick it in the microwave and we turn it on, the microwave will start heating it, and where there are these peaks, you'll have a hot spot, you will bubble up and melt the cheese first. So if we put the cheese in, turn the microwave on, and then pull it out, we can look where the cheese is bubbled up, measure the distance between those bubbled up points, and that will be our wavelength. With the cheese, this came from the dollar store. It's not the world's greatest cheese, but I did put cheese on a manila folder and cooked it. And we have a major spot here, we have a small spot here, one here, one here, one here, one here, one here. And if we start measuring the distances, cheese doesn't stand up very well. If we measure the distance between points, that's 12 centimeters. The distance between these two is 12 centimeters. The distance between these is 12 centimeters. The distance to that small one is about 12 centimeters. So there's a fairly consistent pattern. And if you put in a wavelength of 12 centimeters or 0.12 meters, and you multiply 0.12 meters times 2,450,000,000 vibrations per second, you end up with 294 million meters per second. Somewhere on the order of 150 million miles an hour. And if you look up the accepted speed of light, it's about 300 million meters per second, actually 299,998,000 meters per second, so roughly 300 million meters per second. We're within about 2% of that value. So using a microwave oven, some processed cheese, and measuring between the burnt marks, we're able to measure 150 million miles an hour within a couple percent. That's the type of thing you can do when you use waves and understand them. Good stuff with waves.